Welcome to the Petrus webinar series. We'll get started. My name's Jason. I'll be running the webinar today. This is the first in a series. Petrus has been around, we're celebrating our 40th year now, so we've been around quite a while. We started off as a mapping company and have grown to mapping and database innovations, and we're growing further and adding more in as we get along. We have several different suites that we cover. So we've got the Petrosys PRO, which is our advanced subsurface mapping software package. We have Globe Claritas, which is our seismic processing package, PLDB, which is a prospects and leads database, DBMAT, which is a master database management solution, Enterica OneView, which is helping us to discover all of our software and data that we have stored across our systems, and EPShare, which is a comprehensive solution engineered for subsurface teams looking for data management, and GPinfo, which covers the Australian and PNG and New Zealand EMP databases that people can find and look up wells, permits, and seismic information. So as I said earlier, this is a series, first in a series of webinars. So today's we'll be looking at georeferencing techniques, how we can georeference an image. And then on the 21st of November, Abilio will run through seamless digitizing raster information from the image that we digitized today. And then Ryan from the UK office on the 7th of December will have a look at converting the raster image into a grid. So keep an eye out for those, and please join us for those sessions as well. So the functionality of Petrosys PRO, as we've grown over the last 13, 14 years, you can see here that we've added a lot of different functionality into the software. So the architecture's grown. The 3D viewer now includes a cross-section package in the latest version of Petrosys PRO, and the connectivity has expanded. Surface modeling options have grown, and so has the infrastructure that we have in our mapping software. So getting into displaying a georeferenced image, displaying and georeferencing an image. So we'll go into how we display an image that contains georeferenced information. So to do that, we just simply display the information, display image on the map, where that can be a raster or a PDF, and it will automatically identify that it has georeferencing information in that image and automatically turn that on to display it in the correct location. So if the image isn't georeferenced, you can see here that the outline of the Australian coastline doesn't line up with our outline from our shapefile. And once we georeference that image, those tie together. So we can display a wide variety of georeferenced images in Petrosys, including PDFs, ECW, GeoTIFF, and JPEGs. And we can also display them via WMS as well. So why would we want to georeference an image? So if we're using images from farming opportunities that aren't georeferenced, we may want to georeference those to tie them in and line them up with our existing information to see how that ties in and see if it's worth farming into that opportunity. When using images scanned from old reports where we don't have a digital copy, we can scan those in, digitize those images, and then extract information from those. Or when we're using images from a digital report that don't contain georeferencing information. Or if we get an image that's sent to us, but we look at it and display it on the map and we realise that georeferencing information is wrong, we can turn that off, just display it itself, and then re-georeference that image. And also it allows us to extract information from those raster images, such as point, line, or polygon information, such as well locations, field outlines, field pipelines, faults, and things like that. And we can also extract the grid from that raster image as well. So to georeference an image in Petrosys, we start off by opening up the mapping module, and we can then display that image in the mapping module. So display raster image, or select the display image icon. And then once we've displayed that image in the map, we click on that image to select it so that the red box appears around the outer edge of the image. And then right click on that image, and from the drop down menu, select georeference image. We're then presented with a new panel, and in this panel we've got a few different things that we need to set up and select. We need to specify the output file format, whether that's a GeoTIFF, ECW, or JPEG. Whether we want to set the output coordinate type to geographic or rectangular. and whether we want to set the output CRS. We would ideally set the output CRS to what we've identified that the image is set in to start with. Select the output georeference options. So we can select whether we want to tile that image. If it's a large image and we want to split it into tiles, we can do that here. If we've selected the JPEG, we can select the quality or the compression rate. We can select whether we want to do it world, affine only. So they've got several different options here and how we want to set that up. So the compression type and quality, whether we want that world, tiled or affine. And the last thing, which is the most important, is setting our control points, which we'll have a look at here. So the control points are used to tie the image to georeferencing locations, so latitudes, longitudes, or eastings and northings. And we need a minimum of 3, and we would use the minimum number that give us the correct output. So it's a pair of locations. We have the first location that we select is on the image itself, which is the image that we want to shift. And the second crosses are the location where we want to shift that point of the image to in real world. So where the coordinates want to tie to. So the images can be georeferenced against the geospatial file, such as a shapefile. Here we have the shapefile displayed of the coastline of Tasmania, and we're tying that image to that coastline. Or alternatively, we can tie it to grid lines on the map. So here we have on the map, we've got grid lines along the side, tick marks, so we can read those tick marks off, identify the corners of that map, and then tie it to those corners. So the quality of georeferencing an image works by applying a smooth mathematical warping to the original raster image, and it resamples those pixel colors, and to ensure that we don't get problems such as holes where the image is flexed, it warps those to tie those and fill in those holes. So the accuracy of the georeferenced image depends on the projection used for the original raster image. So we want to try and use the same CRS, the same projection, whether that's geographic or rectangular. The number of distribution of control points or CPs, we want to make sure that we use the minimum number to give us the best result. And the quality of the geospatial data that we use to georeference against. So if we're using a shapefile to tie it to, we need to make sure that that's a good quality shapefile. If we're going to tie it to the coordinates of the map, we need to make sure that we've set that up correctly. And also the resolution of the raster image. If it's a rough grainy image, it might be difficult to tie the points together. So now I'll run through a demonstration. So here we have a map of Tasmania, and we're going to display an image. So here we have a Sorel Basin figure from a Sorel article that the Geoscience Australia have released. So this is free information that you can all access. So I've picked up that figure display here. We're going to display it not from the map, we're going to display it in the world so that we can then place interactive placement and allow dragging. And we noticed on the original map that this is a geographical map, so it's got latitudes and longitudes that it's tied to, not eastings and northings, so we'll set geographic here. If we wanted to clip it to boundary, we can do that. So when it goes outside of our map boundary, it will clip that image away, but I'll just leave that for now and we can turn that on later on. So if we click OK to that, I can then have a crosshairs, I can click and drag holding down the mouse button on the map to display the image on our map. You can see here that the map doesn't tie in, it's warped. So to georeference it, we select the map, right click and georeference image, and that opens up our new panel here. So I can select whether I want it to be a GeoTIFF, JPEG 2000 or ECW, and depending on which one I select here will determine what I can do here. So at the moment it's not a JPEG, so I can't select the JPEG DPI, but if I change that to JPEG, I can then set the DOPS per inch that I want to use here. But I'll set that back to GeoTIFF, and I'm going to leave it as uncompressed, so we're not going to do any compression of the output image. We need to set the output coordinate type from rectangular to geographic, and then the output CRS that we want to use, which in this instance is GDA94. Once we've got that set up, we also need to put in an output name. So I've just got the Sorel Basin figure 3, and this time I've added georef into the image name so that I know that that image is the georeferenced one. And the next thing that I need to do is add my control points. So what I've done here is I've already gone in and I've looked at these corner points, so I know roughly where they are. So what I'll do is I'll just double click on one corner, and in this instance I'm going to type in the value so I can put that corner point wherever I want. So double click here and I'll zoom in and click on the corner, click that elsewhere, move this out of the road, and I've got this image position. Actually, I'll just cancel that. I'm going to do this one first. And then this corner point here. And then you can see that I've got the latitudes and longitudes for these points. And I can then type those in for what I know that they are. So I know from reading off the corner points, if we zoom in, we've got these on the map. So we can use those to measure the actual corner points of the map. So this first one, 141.05. I didn't put a space, 141 space 05. This is 39.15 south. 49.20, and again 39.15 south. 148.05 and 44.25 south. And 45.35 south. And you see, as I do those, these crosshairs or the image positions change. So now when I click apply to that, we can see that that image is now warped. And if I slide this translucency across, you can see that it's pretty close location, but it's not quite right. So we may be happy with that. So if we zoom in to these corners, we can see here that it's close, but it's not quite right. So if I'm not happy with that, I can revert to the original image, apply that translucency, and then instead of using the corner points, I can zoom in on an area, change the position that I'm shifting it from, and this time we can use the map. So I've shifted the first control point, then we can shift the second control point. So we pick it on the corner of King Island. And we can zoom right in if we want to make sure that we get it perfect. And we can shift here, we can zoom in, pick the bottom corner of Tasmania. So it's a good point to select is the corner of this island. So we can put that down here, moving it from this corner point of this peninsula to the corner point here. And then the last position that's a good position to select is the tip down by Strawn. So we can zoom in Cape Sorel. We can put it on the tip of that peninsula. Zoom in up here and put that on the tip of the peninsula. Now when I zoom out and click apply again, we get a much better tie of our coordinates to our map. So once we're happy with that, and we've got the georeference output file saved, we can click OK. That will then overwrite an existing one that I've done as testing. So we can click yes. We've now georeferenced that image, and it automatically replaces the image in the one that we selected to display. And now if I want to, I can click to map boundary, click OK, and now it trims off that bottom section of the map, and we can see that we've got our map displayed. If I drag it down below our shapefile, you can see that we've got a pretty good tie, and then in the next series we can come back in and have a look at extracting some of these faults and extracting this grid from this raster image using the spatial editor. Thank you for your time, and we look forward to seeing you in the next Petrosys webinar.